Now, business analytics is not a new concept. Insurance companies have been using it as part of their actuarial department for 200 plus years. The whole concept of actuarials and underwriting, risk underwriting, is all about analytics. Manufacturing companies have been using it for supply chain management. Any industry, for that matter, have been using some form of analytics. The entire marketing is based on analytics. Now, as a concept, they've been there quite a long amount of time. But what really is driving the requirement for analytics today? Why is there a lot of hype in the market? And what exactly is going on now? Now, if you look at it, there are a number of types of data sources have become available today. For instance, as a very simple example, you would have come across the concept of telematics, and as an example, insurance companies using usage-based insurance. So what they want to do is to give you an insurance policy where the premium that you pay is based on the way that you're using your car, over and above the quality of the car and the quality of your driving. So essentially, if an insurance has to be purchased, it is based on, at least in a Western country context, it's a combination of what's the current condition of the car and what is your driving history. Those are primarily the two major factors. Now, what they want to do is to really look at the way that you're driving the car and then accordingly give you a discount or increase the premium. So there are different things that companies want to try out to make them more competitive in the market. Now, traditionally, insurance companies do not have that capability of processing information like this. Now, you would have come across a concept of telematics where people fix either a GPS kind of device or something that is connected to their mobile that shows how exactly they drive. And these devices have been predominantly built by the maintenance or for the sake of garages to look at the performance of the cars, in terms of engine performance, in terms of O2 sensor and the exhaust pipe to see if there is any leakage or the engine's misfiring it. So those are the kind of information that they want to do. Now, this device, which has been predominantly built by a manufacturing industry, a finance industry company like an insurance company is interested because by looking into that kind of an information, they're able to get additional insights about you as a driver and they can position more competitive products in the market. So that's the intention of a usage-based insurance. Now, what is changing today when compared to what was 20 years ago or 40 years ago is that the data available for insurance companies to look at information differently to get a better customer insight is now changing. Now, this is true not just for insurance company. You take any company, whether it is banking industry, whether it is healthcare industry, whether it is a manufacturing industry, transportation, news agencies, elections, all of them, there's immense amount of data available and they have to tap into it to get better insights. Now, this is driving the job market today in terms of analytics. There are two distinct topics that has come up. One is big data, the other one is analytics. Now, big data is predominantly an infrastructure play where you are looking at large volume of data and you are trying to figure out how exactly do you manage that so that subsequently you can apply analytics on top of that. You can do big data on its own separately without much analytics. You can do analytics, whether it is small data or big data, but you can also do big data analytics as a combination. There's an intersection point. So the question is, on a big data scale, how exactly or how differently would you do analytics? So these two topics are distinct, but there is a fair bit of overlap that will happen eventually between big data and analytics. So these are some of the concepts that keeps coming. Now, people have their own definition for analytics. If you look at two of those definitions, what you see on the screen, what you are seeing is Ronald Coase, one of the famous economists, I think he's a Nobel laureate as well. He made a statement: if you torture the data long enough, it will confess. It's almost like a criminal investigation. But having come from the industry, it's actually not a joke. It's actually a very, very serious statement that most of the analysis that we will do, you will have to imagine that you are actually in an interrogation room and you are actually torturing somebody for information. And that's how you actually build complex models and even understand the data much, much better. All the models are approximations. So essentially, they're all incorrect. They won't be accurate, but some are useful when compared to the others. So there's a question: analytics versus machine learning. I'll come to that, Arun. So if you look at, there's a fair bit of overlapping concepts. I'll pop the screen. You would have come across a number of terminologies like data science, machine learning, analytics, prescriptive analytics, prediction, descriptive statistics, classification, clustering, on and on. Artificial intelligence, text mining, sentiment analysis, machine learning, Azure machine learning, Spark, Hadoop, big data, streaming, optimization, word cloud. There are lots of terminologies being thrown around. Okay, and you would see that many of these concepts essentially overlap with each other. Now, what I would do is, just for sake of simplicity, for this part of the session, please imagine that data science is an over-compassing world of data analytics. It is something which you can call end-to-end, where there is business requirements, there is data, there are technology, there are algorithms, there are people who leverage all of that, build their own algorithm, build their own things, and then they come out with solutions, implement it, keep monitoring the solutions, and constantly looking at improving it. Okay, so to me, data science comprises of all of that. It's almost end to end. Anything related to analytics, including big data or not, everything is included under data science. Machine learning, you could imagine, is like a subset of this, where there are algorithms being written and the algorithms learn from the data. Essentially, algorithms try to do a prediction or understanding of what your data is trying to tell you. There is usually a target variable, like the sales in a company, profit in a company, the cost of operations, some kind of a target variable, whether something is a benign cancer or a malignant cancer in the case of a cancer test. And the machine tries to understand the characteristics. How do I even understand that something is a cancer? By looking at other symptoms, whether it is the number of red blood cells, the platelet count, WBC, could be the temperature, amount of fever. Considering all of these variables, trying to predict or even explain cancer or any other disease with a set of other things, that would technically go under machine learning. A machine learning, again, it constantly tries to learn. So more and more data that you supply, it tries to refine its thinking around how to predict whether something is a cancer case or not, whether something is a fraudulent case or not. So that is machine learning. Analytics is also, again these concepts are overlapping. Okay, analytics is a term that typically is used to explain what has happened in the past, less so for predictions. Okay, so it is all about explaining. Now, if you want to do an analysis on how the hell Trump won the election, right? So if you do an analysis on that, technically that goes into analytics. Now, if you want to constantly use that to predict newer surprises in the future, then that might go into an overlap with machine learning. Okay, there are something called predictive analytics, descriptive analytics, prescriptive analytics. A lot of these terminologies you are thrown around. Normally, predictive is basically, let's start with descriptive. Descriptive is something where you are explaining what has happened in the past. With that, you create a model that explains what has happened in the past. Use that model to convey what is going to happen in the future. That is called prediction. With that prediction, giving a set of options to your end customers. This is what you should be doing based on the data. Then that becomes prescriptive analytics. And you have a whole bunch of other terminologies that are being thrown around, like neural network, deep learning, regression, classification. So all of that is what we try to cover in our sessions to bring a very simplified explanation to all of these concepts. Let's go back because there was a question. I addressed that. If you look at simple examples like retail industry, help in identifying profitable customers when compared to others. What kind of promotional offers you want to give, right? Tesco is well known in UK for the loyalty card. So they provide a lot of coupons. And the coupons, the way that they are determined is based on your own purchase pattern. But they don't make it extremely specific to your purchase pattern, because sometimes people are paranoid about Tesco knowing every single purchase that you are making. So they might throw in a few bouncers or googlies in between of products that are completely unrelated to what you may want to purchase. But it's an excellent example of identifying customer needs and trying to create promotion offers which is customized for a particular customer, and you create a superior environment. Another example, again, if you look at Internet of Things, IoT as a concept, there are a lot of advancement happening. Now there are a lot of wearable devices people use: Fitbit, Nike Fuel Band, Jawbone, and these instruments have been predominantly built by the sports industry in the manufacturing sector to promote healthy lifestyle. Now these are leveraged by doctors, by the healthcare industry, even by medical insurance companies, to look at the active lifestyle, whether you have an active lifestyle or not, and accordingly, give you some advice. There was one incident where I wouldn't say the teen's life was saved by Fitbit, which is probably an overstatement. A teen did have a medical condition, and what happened was she immediately checked into the hospital, and the doctors were able to reconfirm their diagnosis based on the heart rate during a particular time from the Fitbit device. So that enabled them to do a faster diagnosis and then create some corrective actions accordingly. So you might, the way that an instrument which is completely unrelated to a medical industry, how it has made an impact to an individual is something that we wanted to cover. So these are the kind of examples that we will be covering in those sessions. Now let's take a very simple example of how to convert a business requirement into a analytics requirement. Okay, the business requirement is typically on a very, very high level. Now you might be an individual who is running your own company. You might be someone who is working for an organization which specializes in analytics. You might be working directly in the industry. You may not even be an IT resource. You can be working directly with a business as a business analyst. You can be a head of department in a particular organization. Now, analytics is for everyone. It's a way of you doing your day-to-day job much better, using some newer tools, using data to help you understand what is going on and take corrective actions. How to look at data differently. So a simple business requirement might start off something like this. A restaurant chain wants to open a new branch in a new location. CEO asks a very simple question: how much money will we make per month? So how do we solve this, right? A very, very simple equation. So the first thing is, it's a restaurant chain. So obviously there are other branches of the same restaurant where you can go and collect the data in terms of the monthly revenue. And in the absence of any other information, you can simply take an average of all the other restaurants and just say, on an average, you might do about 1 million a month. But if you look at the other restaurants, some of them might be making 500K, another one could be making 3 million. So there's a huge variation from 500K to 3 million when the average is at 1 million. Okay, so even though you might think that you are doing a safe bet by saying the average is 1 million, you might be way off. You might be off by about 500K because one restaurant does as low as 500K. Another restaurant is doing as high as 3 million. That's a significant difference, even though your average is saying 1 million. So how do we go about solving it? So a simple question like how exactly is the revenue of a restaurant coming through? You might look at number of parameters like, how is my revenue impacted? So location would be the first thing. Where exactly is my restaurant located? Is it next to a business establishment? Is it within an IT company? Is it within a huge chain of business, offices space? Is it on a main road? Is it hidden? Do I have fine dining or is it fast food? The number of tables in my restaurant, or people just going away because there are not enough tables? Do I have AC or not? Especially in an Indian context, that could have an impact. It could depend on the menu card. Some people talk about happy hours. Some people talk about smoking joints available in the restaurant. So there could be potentially hundreds of reasons based on which a restaurant's revenue could be determined. So you know that as your hypothesis, you might think that these are the potential factors that contribute to a revenue in a restaurant. But how do I know how much money I will make? So what we would do is, for the information that we have collected, we will put together a model with our existing restaurants, collect the same information in terms of their revenue. Do they have fine dining or not? Are they right next to a main road or to business establishments? Is that a residential area? Do we have enough parking spots in that place? Are they open longer hours? Are they open 24/7? What kind of menu do they have? You collect all of that information along with the revenue, which is the target variable, for my existing restaurants. Then you put together a model. Okay, a model is basically a logic which the analytical modeling, the techniques do. There are different type of techniques for different type of requirements. With that, we create a logic. The logic will come back and tell us that these are the important variables that contribute to a revenue. You might, even though you would have thought about 100 different variables, potentially the 6 or 7 are the ones that are making maximum impact to how your revenue is structured. Okay. Once it is done, it also gives you an insight about the number of parking spot. By how much does it really impact the revenue of my restaurant? Okay. Having a fine dining or not, how much it actually impacts the revenue. To that level, the models are able to specify. So once you have created the model, then for the new location, you go back and collect the same set of variables which have been deemed important, apply those, then you get an answer to how much money you will be making per month. So you have done an analytics part of understanding what has happened with your existing restaurants, made a model out of it, and use that for predicting what is the monthly sales. Now, obviously, there could be other varying parameters to this in terms of the monthly sales varies year on year, month on month, because there could be some seasonality, some trend to the overall equation. But I guess it's all part of the learning. Okay. So this is how we convert a simple business use case into a detailed analytical step. To summarize, if there are a few steps that we want to describe how an analytics project is created, a customer has a business problem which is typically at a very high level. Sometimes it is vague, that you have to actually work with them to detail out the requirements. You identify what are the factors that contribute to your target variable and by how much. You start off with an hypothesis, you validate that, you identify the data which are important, you apply the techniques, and then you come back with some inferences and recommendations. So those are the typical steps that we follow in an analytics project. The analytic stages itself, if you look at it, there are 3-4 areas that we would be looking at. One is data exploration. Now, all of us at some point in time have done data tabulation and visualization. We have created bar charts, pie charts, We have created simple table summaries, which is essentially your first and second box, or where it fits in is your first and second box, data exploration, visualization. But we have really touched the tip of the iceberg. There's significantly more amount of work that we could do as part of analytics. Once we have done data exploration, visualization, identified the symptoms or the key heat map or key hotspots, where exactly your problem lies or what are the contributing factors, then you go into complex modeling. All your business problem can be handled across two different analytical technique. One is called supervised, another one is called unsupervised. Within supervised, there are two types like regression and classification. Under unsupervised, there are a few techniques like clustering, principal component analysis, market basket analysis. Now, if you talk about neural network, deep learning, random forest, logistic regression, linear discriminant analysis, naive-bayes algorithm, you talk about any of that, they all fit in within these two categories. Either it goes into supervised or it goes into unsupervised. Okay, this is the simple framework structure where we fit in every other algorithm that has been written. If you're thinking about topic modeling, understanding similarly spoken topics, there is some trend in Twitter which is talking about demonetization. There is some threads in Facebook which is talking about demonetization. Somebody else is talking about Jallikattu in another context. If you want to link all the articles which talk about a similar topic, we call that topic modeling. That fits into unsupervised analytical technique. So somewhere or the other, the models fit in one or the other box. Okay, when you have a target variable, it is called supervised. If you're really fishing for information, it is called unsupervised. Now all the techniques that we typically learn fits into these two boxes. Okay, so just to summarize, the approach for analytics project looks something like this. The analytical techniques itself that has to be learned to understand and apply in different contexts looks something like this. The way that we would go about learning this looks something like this. It's a 6 weeks course. The idea is to look at foundation, understand data, how to deal with data, how to treat data, how to clean data, how to transform data, how to get an understanding of what data is all about, the sources, how do you do sampling, the types of data, unstructured, structured, image, audio, video, all of that is included in the foundation all about data. Second week, we pick up one statistical topic or language called R. We will learn that how to do data exploration, storytelling with visualization as part of that. We move on to supervised technique of regression and classification. We look at 2 or 3 examples. There are many types of regression, many types of classification. We look at few of them. Week 4, we predominantly focus on unsupervised learning like clustering. We also look at a few more classification techniques like neural network, XGBoost and SVM. Now these techniques are popular in the market, which is why we are bringing to you. The next topic is called text mining, where we look at unstructured data. We also look at market basket analysis and principal component analysis. Last but not the least, we do a session on big data analytics. We will cover some IoT aspects. We'll also do time series analysis, which is slightly different from your regular analytics. This gives you a sense of what analytics is all about. Now, what we would like to do, everything will be hands-on from week 2 onwards. The idea is that at the end of this course, you should be in a position to go and deliver an analytics project on your own with limited support. It doesn't make you an expert, but you will be able to do that. Now, if you are working with organization or if you are heading your own company, now you understand how different techniques are applied in different contexts. We will be doing quite a number of use cases across different industry, including banking, insurance, mobile or telecommunications. We will look at something in manufacturing. We will look at different examples across all of these areas so that you have a well-rounded appreciation of analytics across all the industries. Now, if you have specific area of interest, please do let us know. So we can also ensure that we have some use cases. If you have specific problem statements and if you want to know, hey, how do I go about solving this, please bring to this session as well. Because at the end of the day, there are three broad lessons learned that you will have. Number one, what you will take away, you will have a new skill set of R statistical tool, essentially where you can do an end-to-end project with one language, which has the capability of every single methods that you could think of in the world of analytics. I specifically picked up R because people who come with non-IT background can also pick up R easily when compared to other languages. It's mostly scripted. It's one line of code, even to call a neural network. So it's quite easy. The second thing is you will have an understanding of all the analytical techniques, what context, what do we apply what. Okay. The third but not the least is the soft skill in terms of how do you even apply creative techniques and think through this before you solve complex business problems. I think that is an important thing that is not spoken. If you go to the market with all this analytics course, people will spend a lot of time explaining to you about regression, classification, neural network, random forest, all of that. But the models have their limitations. The only way the models will improve their quality of their output is if you get your week one right, which is all about data, the quality of the data, the way that you need to look at the data. Okay, how differently, how creatively can you transform the data to look at it differently, which is covered essentially in your week one and week two. You will not find a lot of people actually stressing on that. But if you look at the models themselves, the best performing models in the world actually has a better handle on the way data is managed, which essentially we cover in our week one and week two. How exactly is that managed? How do we bring different data types? How do we know we are actually stuck with our model? What differently do we have to do? I think that is the kind of things that we want to bring with some practical examples of this. Okay, so we have picked up R. What are the competing products in the market? If you don't have R, you can try with Python, which is also free, SAS, MATLAB, and Julia. And let's not forget our Excel, which is the most widely used analytical tool in the world, which is brilliant. It just has some space limitations. Otherwise, it is one of the best tools that you can use. Purely from a visualization perspective, there are softwares like Tableau, SPSS, ClickView, Power BI. R has got some brilliant packages. Python, MATLAB, they all have their own visualization. But there are some products like Tableau, which is mostly drag and drop, which seems to be quite famous with the business analyst crowd because you don't have to do any scripting. It's predominantly drag and drop. And I would say 80% to 90%, maybe 90% is an overkill, maybe 70 to 80% of what a sophisticated software like Tableau can do, you can do that in Excel itself. So if you look at Tableau, they've actually evolved Excel to a much, much higher level. Tableau definitely has got other features, but from a reporting perspective, I guess Excel itself is great enough. Again, it is the way that you bring the data into the system where maximum amount of time is spent. So that is not stressed well enough in the market, especially in the training institutes. So I think that is something that we will cover as we go through the training, even though we also cover the techniques under different scenarios, but we also spend some time going through problem statements, struggling through it, and then trying to get out of it, because that would be part of the lessons learned. So we deliberately create some data where you struggle with cleaning up the data. I think that's part of the lessons that we will cover as part of this. Okay, let me just pause here and check if you have any questions in terms of the course structure, in terms of any topic that you think has to be covered, must be covered, not very clear. I'll just pause here. I'll just give you a timeline. We are looking at 6 weekends. We would do a 3 hours on a Saturday, 3 hours on a Sunday. I think Mahesh, I think only you are from UK. So I'm thinking that we will probably start at 10 10:30 in the morning, or we will do an afternoon session. It might be a bit too early in the morning for you, but we can work through that. I'm slightly flexible, either morning or afternoon. We can work through that from an Indian context. I just wanted to see, do you guys have any other questions?
So Karthik, Mahesh here again.
Hi, Mahesh.
Can you hear me, Karthik?
Yeah.
So, so a couple of things on the data quality side.
Right.
Every industry has its own way of ensuring data quality. Yeah. So data quality is a big subject. How do we ensure? Are we putting in the right data quality rules and ensuring the right data is going into the statistical model or reporting, or do we have any kind of documentation or principles around it?
Okay, so we actually start other way around. What we do is, a lot of people, when they start analytics projects, if I ask a very simple question, where do you start? Everyone says data, but it is the wrong answer. It is the wrong answer. Everything starts with a business problem. If you look at the business problem, for instance, the revenue of a restaurant, I'll just reuse the same example. For me to determine the revenue of a restaurant, I need to look at number of parameters. Is it dependent on the number of parking spots? Is it dependent on number of tables that I have in my restaurant? Is it dependent on the number of hours of working? So I ask all of these questions. There could be 100 odd questions. Now,
so you have a survey kind of stuff, right?
Yes, it will be a creativity session. It's a workshop that you will have to do within your own organization with your team, asking all of these questions without any limitation. There are no stupid questions here. For a simple question like what is going to be my revenue, you will actually have 100 potential insight questions for which you need to find the answer. Okay. Now, 100 might look like an overkill, but let's go through that. The way it works is you initially ideate, and then you literally do a brain dump in terms of your thinking, in terms of what could be contributing, and there are some structure you can put into that, which we will cover. Once you do that, for each of these insight questions, you then ask the question, where is the data going to come from? Okay. Normally, organizations have a tendency to put data into a data warehouse and then try to clean up and the data quality and all of that. That is part of internal organizations' data quality principles, or rather data management principles, right? Now, in the analytics world, the internal data is one data source. There are 4 other data sources for analytics. One is external, that is coming from the market, from your internet, from your government publications and all of that. The other 3 are something that is generated newly for your analytics requirement. So one example is the survey. Second example is the observational data, because people generally does not respond to surveys, so you don't really get the right value. Third thing is for a clinical trials kind of thing, where you generate data through some kind of a design experiment and then you try to do your analysis on that, right? So an internal organization's data source is just one, which even though it is 60 to 70% of the overall data available for a business to do, there are some existing principles from data warehouse. We don't cover that. It's already there. Our thinking is, I want to start from business requirement and I break it down into a lot of insight questions. Okay, for me to answer this particular insight question, what is the data that I have? Collect the data, and then as part of that, I go through it and understand, does it really make sense? Does it have all the information that you're looking for? Then you realize that the organization is not even collecting the data it is supposed to collect in the first place. This is the kind of discovery we go through as part of it. For example, we did one project for an online e-commerce site, and they want to come back and say, hey, we want to increase the number of people who are clicking on the advertisement that we are sending on a day-to-day basis. Okay, so we asked, how many emails do you send out? Every registered customer, we send 2 emails per day. We said, that's not going to work. Okay, so give us some information like age. Tell us what they have purchased in the past. Can you give some information? Then when you go through that, then we realize that these people don't even collect the age of the customers, which is an important thing, because as an online e-commerce site, they want to know who's purchasing it, what kind of products, different age group. Then based on the age group, you actually don't send them 2 emails per day. You send them 1 email every week or every other week, which has more products which are specific to their taste of that people of their age group. Okay, so age, if a field is collected and if it is partial, it is poor quality data. Now in this case, it is non-existent. From the analytics world, to us that is poor data because you have not even thought through that you need to collect age. But because of the requirement, now we understand that. I think this is the difference from a data quality collection quality purpose. Mahesh, I don't know if I fully answered your question.
No, it's all right. Probably through your cases, we'll come back to that.
Okay.
The other question I had is about, you said you're going to use R for the development of all your analytics and reporting and all the stuff.
Right.
And you said there are a number of statistical models. Yeah.
Yeah.
How do we choose what is the right statistical model? And I know you're going to come back to the business case again, but even if I come back to a business case like restaurant, for example,
right,
what kind of statistical model would I really match the requirement to? How do I come up with that understanding? Actually?
No problem. No problem. So that is covered in this particular slide. I'll try to cover that. So any type of analytics, the first two steps are mandatory. So again, let me take it back 1 second. If you look at what you see on this slide is the business requirement aspect of it. Okay. So I'm going to ignore that. But let's look at 3 and 4, which is what I have expanded subsequently in this slide. Okay. So the 3 and 4 from this is essentially what it is. In 3 and 4, once you have collected the data, data exploration and visualization is mandatory for any business requirement, period. There's no around it. But what kind of graphs do you use for different insight questions? We cover that as part of the training. What data exploration techniques you have to follow? We cover that as part of the training. When do we have to look for outlier? We cover that as part of this. Now, once it is done, taking a revenue, a restaurant revenue as an example, if you have a target variable and the target variable is a continuous number. For example, revenue is a continuous number. It could be 1 million, it can be 1.78 million, or it could be 400K. So if you have a target variable, it is called supervised analytical technique. So when you put together your insight questions, for example, let's take the same example of revenue of restaurant. Will the number of tables make an impact to my revenue? Okay, so revenue is a target variable, which is a continuous number, numeric. So it is called supervised. Because this is a numeric number, it is also supervised regression technique. Within that, there are OLS, lasso, ridge, decision tree. What we generally do is we try with some 3-4 techniques, and whichever technique gives you the best answer, we use it based on our data. Let's take another example where you want to predict who is going to win the election. Or is this insurance transaction or is this banking transaction, is that fraudulent or not? What you have, fraudulent, yes or no. Fraudulent is a variable, target variable. It has values which is like a choice. It could be low, medium, high. It could be yes, no. It could be A or B. When you have values like that, target variable, it is called classification, which is what you're seeing on the screen, third box. The second option is classification. Within classification, there are some 9 techniques. What we generally recommend is try 5 of them. I have a laundry list of 5 that you should try. Trying out with all of these 5 techniques hardly takes few minutes. It's basically every statistical technique, there is a function that has been created in R. All you have to do is invoke that function, you get the answers. As simple as that. So, but there are 4 or 5 different techniques. We say that, hey, this is a classification problem. This is supervised. So you use one of these 5 techniques. Now let's look at market segmentation. Now, if you want to do a segmentation in terms of your customers, you want to group them together, but there is no target variable. I have collected some information about my customers. I want to see, is there a general pattern of grouping? 50-year-old walking 4,000 steps a day with a height of 170 centimeters, right? They form one group of customers. So, but there is no target variable. It's data that is getting grouped within itself. If you are looking for a requirement like that, it goes into clustering, which is the 4th box first. So every technique, there is a reason scenario in which we use those techniques. Okay, I hope this is the answer to your question that you're looking for.
Yeah, that's perfect. That sounds good. Yeah, that sounds good. I think somebody called Arun has been asking you questions in the chat message. I'll leave them to ask. Yeah.
Okay, Arun, the first one is R can be covered in 1 week. No, Actually, your week 2, week 3, week 4, week 5, week 6, it's all in R. Okay. Week 2 is you are doing your initial baby steps with R. You're trying to see how to read a file. You might read a file from CSV. You might read a file from a database, from a NoSQL database. You can consume data from a XML, from a web service. You might read a HTML page. You might want to connect to Twitter or Facebook directly and extract information. So the exploration part is essentially how to consume data and how to do some cleanup with the data. Okay, so that is what we cover. Storytelling is basically how to use different charts under different scenarios. Okay, so we'll give you ready-made code. You will execute it. It will be hands-on. You will try this out. We'll give you assignments which you will be trying this out. As simple as that. Okay, week 3, week 4, week 5, week 6, everything is based with R. So R is actually learned over 5 weeks. R has got 12,000 plus packages. We can't be learning all of that. So we'll be learning the bare minimum that is required for you to do an analytics project on your own. Okay, so I hope that answered your first 2 questions. Are you conducting any interview preparation classes? I generally give you some structure around how you should attend interviews, but I'm not really preparing people for interviews. I know it's kind of what the concepts that we cover is essentially that. Okay, so project work on real time. Good point. I forgot to add this. So there is a site called Kaggle, Kaggle. Okay, Kaggle is an online site for analytics competition. Real world industries are putting their problem statements there. There are some which are used for practice purposes, knowledge purposes, and there are some that has been put together by real industries and anyone in the world can participate. Okay. Now it is always intimidating to go and participate in these kind of competitions. When you begin, you are just learning. So what we will be doing is, as part of our training, we'll force you to enter into one of the competition. We'll work with you. We will be together. All of us will be making an entry. We'll put our names. We'll all make our individual submissions. You will see your name in the competition. The first one is the most difficult. Then it becomes downhill from there because you will understand how exactly the competitions have to be competed. So I am using that as the means to expose you to real-time projects. Okay, this is a 6 weeks course. Any project takes about 2 to 3 months to complete. So the idea is that we will at least expose you to these competitions. We'll go through some of the use cases that they have specified, talk through it, so that you are in a position to go and compete. Now you don't have to win these competitions. All you need to do is ensure that at least you are there in the top 50%. That will make you feel good about yourself. And essentially it is real world problems. So you will see the accuracy of your model. And if it is not much different from the top, 10% or 20%, what means is essentially you are qualified to go and do analytics projects on your own. So that's the way that we are trying to deal with this. Okay. Arun, I hope I have answered all of your questions. Okay, excellent. So this will again, we'll try to keep it as business oriented as possible. See, everything, because analytics is more closer to business than it is to IT. So I know I keep mentioning, it's almost become a cliche statement when I say business requirement. But if you crack that, it is not the models which makes a big impact to the business. It is the ability to think through the problem, structure it so that you use the right model. So we don't want to jump into neural network or XGBoost thinking that it will give you the best models if we screwed up on the data aspect of it. I think we need to take it slow. Now, when Mahesh was asking, I think I was answering partly that when you start off with a high level of business requirements, it is one requirement broken down into 100 questions. What happens is, as you navigate through the 6 weeks, or rather, as you navigate through the problem statement, when you do data exploration, what you will start doing is, for the revenue of the restaurant, let's say I identified 100 different reasons which can impact the revenue of the restaurants. What happens is, when you start doing your data exploration, you start eliminating some of those. you will find that parking spot may not make a big difference at all, or being a big next to a main road may not make a big difference at all. Okay, it might be other parameters that are more important. So what will happen is this 100 might become 50. Then you do visualization. Again, look at the data. Keep torturing it. Look at it differently. Start trying this out. That 50 will now become 20. Okay, so even though you started creatively with 100 different reasons, when you do data exploration, you eliminate some of them. When you do visualization, you again eliminate some of them. Then once you have a smaller set, when you start applying through supervised analytical techniques or unsupervised, depending on what problem statements it is, what happens is further number of variables are eliminated in the process, and you will essentially end up with probably a handful of variables. For instance, we did a fraud analytics for an insurance client. Okay, so this is to look at claims, insurance claims that has come in for life insurance, and they wanted to build a fraud analytics model. Okay, so we started with some 150 odd variables which they gave us a dump. We started with that, we saw some visualization, we did something, we started eliminating, and we found that there are only three variables that was most important, that was explaining 80% of what was going on. Okay, the three variables were: what is the sum assured, basically if there is a claim that is coming in, what is the total amount of the claim? Higher the claim, more fraudulent it is. Second, how long was the insurance policy in force? Okay, anything that is less than 365 days or 376 days, rather 1 year, that seems to be more fraudulent when compared to other insurance policies which were in force for more than 1 year or 2 years or 3 years. They were less fraudulent. If any insurance policy was active for less than a year, most likely they were fraudulent. Third reason for death, is it because of suicide, murder, accident, or ill health? We found that ill health had the maximum number of fraudulent cases. Others did not. So what happens is that even though you start creatively with lots of variables, but when we do the analytical techniques, finally we'll end up with a fewer set of variables that explains maximum amount of what is going on, and that eventually is what you push into production. Okay, so there is a principle called Occam's razor. Okay, Occam's razor. If you may come across this internet, essentially what this person is saying is that a fewer number of things, keep it simple, keep the model as simple as possible, don't overdo it with too many variables. However, what we when we start off, we want to do the exact opposite and not restrict ourselves, but then with our sound analytical principles and our techniques, we start identifying the right set of variables which has the maximum impact. Okay, so this is what we go through as part of our training. Any further questions? Okay, so I'm not too particular about sticking on to the 6 weeks. Normally, some topics might require a slightly longer duration, sometimes repetitions. So even though we propose 6 weeks, it usually goes into the 7th week. Okay, so we are looking at roughly Feb and March for us to complete this. Okay, we are going to record all the sessions, the deck materials, the source code, some of that will be made available to you prior to the training itself, but some we will hold back deliberately because we want you to go and try it out on your own. Okay, for some sessions we'll give you the code upfront because it makes it faster for us to run through. For some, we would like you to try it from scratch, especially week 1, week 2. Most of it will be from scratch so that you get the flair for it. Then once we go along, some of these techniques, we will give you some existing code. We will be using R Studio to train this. I'll give you the software requirements also subsequently. It's all hands-on, so please be prepared. The decks themselves or any material, I'll give you references to materials in the internet. There are enough material, but whatever slides that we are using, I'm going to make it available through SlideShare. so you can have an access to it once the trade as part of the trading itself. So you'll have access to it so that you can refer back. What essentially we'll be doing is predominantly creating a summary of the training. Okay, I think that is the most important thing for people to know. If you're doing a decision tree algorithm, what are the things you need to remember? I think those are the kind of information we want to provide. We will give you reference material. There are enough free materials in the internet. I will also give you recommendations for online MOOC sites where we would recommend you to go and attend the same training from a different faculty free of cost. Of course, you don't have to pay anything, purely because these concepts are slightly vague in some sense. It is always nice to get perspectives from two different faculty on the same topic. Second, it kind of reiterates the point. You understand it much better. It's very similar to our school. We also go to school, we also go to tuition, even though it's the same subject. Twice the lecturer, the concepts gets into our mind much better. Exactly the same thing which we are recommending as part of that. But the topic itself, you will have a fair understanding of all of these topics with hands-on experience. Any questions, folks? Mahesh, you are okay? Arun?
Yeah, I'm fine. Thanks, Karthik.
All right, thanks, Mahesh. We'll connect offline on the timing aspect of it. I'll send an email once the people reconfirm on it.
Sure, that's fine.
Excellent. Okay, thanks a lot, everyone. Please do reach out to me if you have any further questions offline. You have my email ID. This session I'm going to have a recorded session. I'll upload the video someplace and we'll share the link.
Petrol. You haven't put petrol. That's
Petrol.
Okay. Cheers.